In this section, we're going to look at transformation of a multiplication formula. Here we have a plus b squared. We know that expands to a squared plus 2ab plus b squared, right? So we can say that a squared plus b squared is equal to this expression, a plus b squared minus 2ab, right? If we subtract 2ab each side, then a squared plus b squared is equal to a plus b squared minus 2ab. Just like that, right? Same thing here. A minus b squared is equal to a squared minus 2ab plus b squared. Then a squared plus b squared is equal to a minus b squared plus 2ab, right? If we add plus 2ab plus 2ab, do you guys see that? A squared plus b squared is equal to this binomial square plus 2ab, right? Okay. Number 2, if we have a plus b squared, then it is equal to a minus b squared plus 4ab. Why? If we expand this, that's going to be a squared plus 2ab plus b squared, right? If we expand this expression right here, that's a squared minus 2ab plus b squared, right? So if we add 4ab here, then they're equal to each other, right? Because minus 2ab plus 4ab, that is equal to plus 2ab, right? So this expression is equal to a plus b squared, which is equal to a squared plus 2ab plus b squared. Does that make sense? Okay. If we have a minus b squared, then that is equal to a plus b squared minus 4ab. Why? Let's expand this expression right here. That's a squared minus 2ab plus b squared, right? If we expand this binomial square, that's a squared plus 2ab plus b squared, and we have a minus 4ab here, right? So plus 2ab minus 4ab, 2 minus 4, that's minus 2, right? So that is equal to a squared minus 2ab plus b squared, which is equal to this expression right here, right? Okay, so this expression can be transformed to this expression, and this expression can be transformed to this expression. Number 3, we have a squared plus 1 over a squared. That's actually equal to a plus 1 over a squared minus 2, or a minus 1 over a squared plus 2. All of these three expressions are equal to each other, and I'm going to show you why, okay? Okay, let's expand this binomial square. That's a squared plus binomial square 2 times first term times the second term, right? Plus second term square, 1 over a square, and we have a minus 2, right? Here we have a divided by a. This one cancels out, right? So that's actually what? A squared plus 2 minus 2 plus 2 minus 2, right? That cancels out, right? That goes away. That cancels out. So we have a squared plus 1 over a squared, which is equal to this expression right here. So if we simplify this, that is equal to this, right? Let's simplify this expression right here. Here, 1 minus 1 over a squared, that's a squared minus 2 times first term. Oops. First term is a. First term is a. Second term, 1 over a plus the second term squared. That's 1 over a squared, and we have plus 2 here, right? A cancels out. So that's actually what? Minus 2 plus 2. Minus 2 plus 2, that's 0. So we have a squared plus 1 over a squared. So we see that all of these expressions are equal to each other. This expression is a squared plus 1 over a squared, which is equal to this. This expression, if we simplify this, that's a squared plus 1 over a squared, which is equal to this. Okay, let's look at number 4. A plus 1 over a. This binomial square is a minus 1 over a squared plus 4. Okay, we're going to expand this. That's binomial square, a squared minus 2 times first term times second term plus second term square. And we have a plus 4, right? So this one cancels out, right? Here we have minus 2 plus 4. That's plus 2, right? So that is equal to a squared plus 2 plus 1 over a squared. That's actually equal to this, right? Because if we expand this, that's a squared plus 2 times first term, second term, plus second term square. So a cancels out. That's a squared plus 2 plus 1 over a squared. So we check that, we see that this expression is equal to this expression right here, right? The last one. If we have a minus 1 over a squared, then that is equal to a plus 1 over a squared minus 4. Okay, check this. Let's expand this expression right here. That's a squared plus 2 times first term times the second term plus the second term square, and we have a minus 4. Here, a cancels out, right? So that's a 2 minus 4. So that's going to be a squared. 2 minus 4 minus 2 plus 1 over a squared, right? If we expand this part right down here, that's going to be a squared minus 2 times a times 1 over a first term, second term, plus second term square 1 over a squared. So a cancels out. So do you see that? They're same, right? They're both a squared minus 2 plus 1 over a squared, right? Example number 4. Suppose a plus b is equal to 4 and ab is equal to negative 2. The question is to find each of the following. Number 1. A squared plus b squared. That's actually equal to, that's actually equal to a plus b binomial square minus 2ab, right? Because this one right here, that's a squared plus 2ab plus b squared. So if we have minus 2ab here, then that's going to be, these two terms will be cancelled out, right? So that's just equal to a squared plus b squared. Does that make sense? Okay, so So this expression right here, a squared plus b squared, is equal to all of this. So that is equal to a plus b. That's 4, right? So 4 squared equal to 4 squared minus 2 times ab is minus 2. So 2 times minus 2. So that's 16 plus 4, which is equal to 20. Make sense? Okay, number 2. We have a minus b squared, right? Remember, a minus b, this binomial square is equal to, it can be written as a plus b squared minus 4ab, right? Minus 4ab. Because this term right here, that's a squared minus 2ab plus b squared. This expression right here, a squared plus 2ab plus b squared, right? So if we subtract minus 4ab, then this is going to be equal to plus 2 minus 4, a squared minus 2ab plus b squared, right? They're same, right? So this expression is equal to this expression. So a minus b squared is equal to a plus b squared, 4 squared, minus 4 times ab. ab is negative 2. So 16 minus times minus plus 4 times 2, 8, which is equal to 24. Number 3, we have a 1 over a plus 1 over b. For this one, we're going to find the common denominator to add these two fractions. So our common denominator is least common multiple of these two denominators. We have 1a and 1b. That's just ab, right? So we're going to multiply by b here, and a here. So that's going to be equal to b plus a over common denominator b times a, or a times b, ab, right? Here, a plus b or b plus a is equal to 4. So 4 over a times b, that's minus 2, right? Minus 2 here, denominator. So that's going to be what? Minus 2. As I wrap up with the chapter 1, I want to emphasize once again that we have to memorize these formulas. Okay? Checkpoint 4. Suppose x minus y is equal to negative 5 and x times y is equal to 3. The question is to find each of the following. For number 1, we have x squared plus y squared. And we have to use these two terms, right? These two expressions. Remember, x minus y squared is binomial square. So x squared minus 2 times x times y plus y squared, right? So x squared plus y squared is, if we add 2xy each side, do you see that? Then x squared plus y squared is equal to x minus y squared plus 2xy, right? So the question, x squared plus y squared is equal to x minus y squared minus 5 squared plus 2 times xy plus 2 times xy, 3, right? So that's going to be 25 plus 2 times 3, 6. That is equal to 31. Number 2, x plus y squared. Here, x plus y squared is x squared plus 2xy plus y squared. And x minus y squared is x squared minus 2xy plus y squared, right? So, x plus y squared is, if we add plus 4xy here, plus 4xy, then on the right hand side, we will have x squared plus 2xy plus y squared, right? On the left hand side, x minus y squared plus 4xy. And this expression right here is equal to this, right? So x plus y squared can be written as x minus y squared plus 4xy. So that is equal to, this expression is minus 5. So minus 5 squared plus 4 times xy. That's 3. So 25 plus 12, that's going to be 37. Number 3, we have a fractions, x over y plus y over x. So to add two fractions, we're going to have to find the common denominator, right? Common denominator is xy. So we're going to multiply by x here, multiply by y here. So that is equal to common denominator xy, and we have x squared plus y squared. And we had x squared plus y squared was equal to 31 from the problem 1, right? X squared plus y squared, that was 31. So this is equal to 31 over xy3. So that's our answer, 31 over 3.